Alright, so this video will focus on 2.2, and we're going to be kind of talking about like tessellations and various ways to move objects on a piece of paper. So a tessellation, if you look at all of these different shapes, they're all the same, right? It's this purple bird, the blue bird, the green bird, they're all the same. They're simply rotated or shifted, which we're going to discuss through this lesson. So as a quick warm-up, we want you to plot each point on a coordinate plane. So you'll get your Cartesian coordinate grid and plot it out. Just for this, once you plot it out, we can think about what quadrant it will actually be in. So like this one here will be in quadrant 2. This here will be in quadrant, well, it's in between 3 and 4. This one here is in quadrant 1. Oh, there we go. This one here, 2 zeros right over here. Negative 4, 0 back over here. And then negative 1, negative 3 down here. So that's how you basically will plot these out to make sure you understand how to do that. Next, we'll go over here and it says tell whether the blue figure is a translation of the red figure. Now if I look here, this blue one, if I actually translated or shifted over to the top right, if I just move it upward, so up and over to the right, quick shift, that would absolutely be a translation. It's a movement. So that one is. This one, however, if I'm going from the blue to the red, I'm actually rotating it. I'm going to rotate it 90 degrees, and we'll see what happens here. So again, the slide is a translation. This one here is a rotation or a turn. Therefore, it is not a translation. It is not a shift. It's actually a rotation. So how can you arrange tiles to make a tessellation? That's kind of the whole idea of this lesson. If I look here, here are my various patterns. So this is my tessellation. Here is the single tile, if I look at it. So if I go through, try to identify the various tessellations within it. And if I look here, if I take this yellow piece and then like the bigger piece here, and if I shift it over, shift it down, I have this one. And if I rotate it and so on, I could make this one over here. So basically this right here, the basic design element, we'll call it, is right here. So going here, down, over, up here, and here. That is your basic design element. I'm just repeating the shape over and over, translating it up, down, but that is what the basic design element would be. For this one here, the basic design element, it looks as though it would be right down here. And basically this image is then just shifted over continuously. This one here, my basic design element, if I look for the piece that has to be repeated over and over again, it looks like, actually, if I look at this, I'm gonna get rid of this piece right over here, and it looks like it's just this right here. I don't know if you see it. So basically, if I take this shape and I keep on shifting it over, I will have all of these various shapes here. So this is a basic design element. So it says design pattern blocks used to make tessellation. For each one, draw the tessellation. So for this one here, this is basically taking this and making my square, and then I have another square, another square, and another square, and it makes a larger image of this. This one here, right there. So a total of 4. 1, 2, 3, 4. This is 4. 1, 2, 3, 4. And I'm going to keep on doing this for all of these various shapes. So this one says draw a rectangle and then find the dimensions of the rectangle and then move the vertex up 3 right and 4 up. So it's on a Cartesian coordinate grid. I have my rectangle. So that's my rectangle. I move it 3 to the right, so 1, So move this one here like 1, 2, 3. Use a different color here. And I'm going to move it up from where it was, 4. So 1, 2, 3, 4. And all these points get moved over 3 and up. So I now have this new shape, which if I did it properly, it would fit right on top of this one. But it is moved up 4 units and over 3. So are the opposite sides of the new shape still parallel? I mean, of course, my drawing is horrible here, but yes, it absolutely is. In fact, a better way to do this is to actually, let's draw a shape here. This would be better. So if I have this over here, and I'm basically going to clone this, and I'm just going to move it up and over. That's what I'm really doing. And it says, are the opposite sides still parallel? Absolutely, these opposite sides are still parallel. And can you conclude the two figures are congruent? Absolutely can. You could actually take these pieces here and move it, and it goes right directly on top of it again. Because all that I'm doing is I'm moving it up and over. So this one says translate the right triangle 3 units to the right and 3 units down. So every one of these little things here will go 3 to the right. So 1, 2, 3, and down 1, 2, 3. So this is B and this is B prime. This is C. I go over 1, 2, 3, and down 1, 2, 3. And this one I go down 3 and over 3. And when I connect these together, all these primes, I have the exact same shape that I had before, but now it is 3 units down and 3 units to the right. This one here, it says the vertices of the square, draw a figure and its image after a translation of 4 units left and 6 units up. So I look here, I have 1, and I want to go 4 units to the left. So that would be -3. And positive, if it goes up 4, that'd be -2 plus 4. I'm sorry, 6 units up. -2 plus 6 is 4. This one here is going to be 3 minus 4. And here's the rule, x minus 4 and y plus 1. So I have 3 minus 4, I have -1. And then -2 plus 6 is +4. And look at this table. You can see how when these rules are applied to these ordered pairs, that's how I get these new points. So here's the key idea for the lesson. Make sure you pause it and read it and write it down. And then finally, here we go. The vertices of a triangle are -2 and 2, 0, 2, and 3, 0. Draw the figure and its image after a translation of 1 unit left and 2 units up. So my rule here is x, just write the rule out here. So it says 1 unit to the left, so x minus 1 and y plus 2. So here's my image right here. And if I go y minus 1, or x minus 1, so this is at -2, subtract 1 is -3. And I go up 2, I'm at a prime. This one here, if I take b, subtract 1 from it, so I'm at 0, I'm at -1, and then go up 2, I'm at b prime. And then finally for c, I go to the left 1 and up 2, and I'm at c prime. And that's basically how you would complete all these.